Alrighty, I've been asked to do a quick run through of one of the assignments in the ordinary exam of June 2022, and it's assignment 3 that we'll be looking at. So let's see what you've dug up for me this time. So, this looks like nonlinear regression. Okay, so we're basically given some data and we're asked to fit it to this expression that we have here. So I'm going to start out by grabbing all of my data, and I'm just going to chuck it into Excel over here. There we go. So that's just me putting my raw data into Excel. Actually, that's not going to work because as any decent engineer, I use dots, not commas. So we'll just find the commas, replace them with dots. There we go. Perfect. So now I have my raw data. And we're being asked to fit it to this expression. So let's just grab that, put it into Excel so I can remember what it is. Over there somewhere. And what else are we being told? We're being told we need to estimate the values for A0 and K with some initial guesses. K is 4, A is 0.8. So we'll just go over here and say we have K and we have A0. Our initial guesses were 4.00 and 0.800. So that's initial. And then I have my determined down here. So for now, I'm just going to start out with the values that I think it is. So I think the values are 4 and 0.8. Actually, I'm going to take all of this and just move it over here somewhere so we have a bit of space. Now, I've been told that this is the equation we expect to be valid. So I'm just going to create a new column of calculations where I say this is my predicted values. And then I'm just going to put in the equation I have down here where I say my predicted concentration for some time is the A0 value first. I'm going to lock it in so it doesn't change as I fill down. And I need to divide it by 1 plus K, lock that one, times T, so that's my variable over here, times my A0 again. So that's the one I have there, and I'm going to lock that as well. So that's just me putting in the equation I have down here and saying, okay, I can predict that at time of 1 hour with these initial estimates, this is my predicted value. And then I can fill it down and say, okay, this is what I predict for all of the different times. Then I'm going to take my actual minus my predicted squared. So that's my squared errors, you could say. How much of an error am I making for my prediction compared to my actual measured concentration? So all I need to do here is I take my actual minus my predicted and I'm going to square it. And I just need to do that for all of them. And when I'm done with that, I can sum up all of them like this. So I just sum all of my squared errors. And this gives me my sum squared error. This is the one I want to minimize. The smaller this is, the better my model fits with my actual measurements. So I want to change these two values over here to minimize the one that I have here. I'm just going to jump to my solver, ask it to minimize sum squared error by changing my unknowns or my variables over here, and I'm just going to ask it to solve. And of course that pops up on another screen, but here it is. Solver found a solution, very nice. And it basically tells me, well, the optimal solution that Excel could find in this case is 5.27 and 0.09 for our two, variables. So that's basically the first part of this. Figure out what K and A0 is. I've now done that. I have my results here. And then, I mean, I'll do it, but I already told you for nonlinear regressions, I will not be asking you to do r squared. But if you wanted to calculate it for some odd reason, we can basically, I think I have my equation somewhere. Here we go. All of my lovely equations. I want to calculate my r squared. And the way I calculate that is 1 minus SSE over SST. So I already have my SSE. I just need to calculate my SST. That one I can use a little shortcut and say that's the def, what's it called, squared deviations, whatever, of all of my y values. There we go. Did I do that right? Doesn't seem right. Something has gone wrong. Actually, why do I only have 8 data points? Was that in the assignment? Okay, in my raw data I have from somewhere else, I just had another data point, but this looks fine. So yeah, now I have my SST, and then if I wanted to calculate my r squared, well, according to my lovely equations, all I have to do is to take 1 minus the ratio of those two. So 1 minus the ratio of SSE over SST. My r squared in this case is 0.99992. So that's basically how you can solve something like this, where you're given some data, asked to fit it to some expression, and then usually we give you initial estimates or values you can start out with. But that's basically it.